Welcome. Now, we just talked about empirical formulas, but what are molecular formulas? Molecular formulas are any whole number multiple of your empirical. So, for example, if you had CH4 as your empirical formula, you see how this is a 1 to 4 ratio. That can't be simplified any further. A molecular formula of this would be any multiple. So let's multiply both of those subscripts by 2. You get C2H8. Let's multiply them by 3. C3H12. Multiply them by 4. C4H16, etc. And so you could continue ... So these are molecular formulas. Let me try to... No. Sorry about that. Well, I just wanted to erase, but that was weird. Anyways, so here are some steps to write the molecular formula. So the first thing you need the molecular GFM. What is the GFM of whatever multiple that is? That has to be provided to you. And you also need the empirical formula of your compound. Now, that is something you can solve for if you don't have. You can't solve for the molecular GFM. That has to be provided. But you'll either have to be given the empirical or you'll have to solve for it, which you know how to do already, so it's no big deal. Then you'll find your empirical formulas GFM. So if you have your molecular formulas GFM and your empirical formulas GFM, all you'll need to do is divide them. And then you'll be left with a whole number. And that is the multiple by which you will multiply each of your subscripts by in order to figure out what is your formula, your molecular formula. Now, sometimes writing it out in words doesn't make a lot of sense. But once we put it into practice, and it's a very meticulous process, a repetitive process, a process that is predictable. So, we just do it a few times and you'll get there. So one more time, you need to be provided the molecular GFM, and you'll either be provided the empirical formula or you'll have to solve for it using the skill set we already have. Once you have your empirical formula, find its GFM, divide both GFMs, molecular divided by empirical, and then you'll be left with a whole number, multiple. And that multiple is what you're going to multiply each of your subscripts by. So let's just give it a whirl. Okay. The substance's empirical formula is CH2O. So I was provided that this time. That's nice. And its molecular mass is 180 grams per mole. What is your molecular formula? Okay, so the first thing we need to do is we need to find the empirical GFM, because this is the molecular GFM. So we have CH2O. So we go to periodic table. We say, okay, so this is 12. This is 2 times 1. 1 is the mass. There are 2 of them. This is 16. Add them up, and your empirical GFM is 30 grams per mole. So your molecular is going to be divided by your empirical. So this is 180 divided by 30, and you get 6. 6 is the multiple by which you multiply all of the subscripts of your empirical GFM. So my empirical GFM was CH2O. So this is a 1 and this is a 1, which we would never write. But just for the sake of this example, I'm going to multiply this by 6. And so then I'd get C6. I'd multiply this by 6. Then I'd get a 12. I'd multiply this by 6. And I'd get a 6. This is my molecular formula. Now, if my empirical is CH2O, I could have had C2H4O2. I could have had C3H6O3, C4H8O4. I could have had any of these, but the reason why this is the answer is because I was told the mass of it. So none of these are correct. There you go. Now that was easy because I was provided the empirical formula, but what if I had to actually solve for it? It's still straightforward, you just have to do another step. what is the molecular formula of a substance if it's made up of 30% carbon, 5% hydrogen, and 40% oxygen? And then the molecular GFM is 300 grams. So first thing we have to do, change percentages to grams. So that's 30 grams carbon, 40, I'll go in order, 5 grams hydrogen, and 40 grams oxygen. So that was our first step, percentages to grams. Then I need to divide by GFM to get moles. So I'm going to divide this by 12. I'm going to divide this by 1 and divide this by 16. So 30 divided by 12 is 2.5. And now those are moles of carbon. Go ahead and use your units. 5 divided by 1 is 5 moles of hydrogen. 40 divided by 16 is 2.5 moles of oxygen. Okay, great. Once I have my mole ratio, I divide each by whatever's smallest. So the smallest number is the same, actually, in two cases. It's 2.5. So divide this by 2.5, this by 2.5, this by 2.5. So that's going to give me a ratio of 1 to 2 to 1. What do I do with those ratios? Those are the subscripts. So I'm going to get C with a 1, H with a 2, and I need to write that, and O with a 1. This is my empirical formula. Oh, look, it's the same empirical formula as last time. I just had to derive it this time. Okay, so now that I have that, I need to find my empirical GFM. You might remember it from the last slide, but just in case you didn't, carbon is a mass of 12, hydrogen is a mass of 1, but there are 2 of them. Oxygen is a mass of 16. I add those up, I get 30. So now I have my empirical GFM of 30. My molecular GFM is 300. So 300 divided by 30 means I have a 10. That is the factor by which I will multiply each of my subscripts. So if I have C1, and again, I would never write a 1 except for the sake of example. I'm going to multiply that by 10. H is going to be a 2 times 10. And O is going to be a 1 times 10. So then my final formula, my final molecular formula is C10, H20, O10. And that is my molecular formula. So again, I could have had any combination of subscripts, but due to the fact that I had the molecular mass of 300, it led me to this particular molecular formula. Again, if you have any questions, please reach out. Thank you.